notes. You've seen this, but I'm not going to go through it again. Fairly important. So, yeah, so this is a normal curve. The idea is that, like, let's say we're looking at people's heights, for example. Most people are just kind of in the middle or pretty close to average. The further away from average you get, the less people there are that fit that description. So if we were looking at like male heights, for example, Mr. Packard is probably over here. There's just not a lot of people that are the same height as Mr. Packard.
It's Dr.
Dr. Packard. Most males would be in this window here, and then I'm like somewhere over here. So the taller this is, it's like a frequency thing. So the taller this is, it means the more often it happens. The shorter this is, it means the less often it happens. Yeah, so the middle is the mean. So that mu means mean. And then we go one standard deviation to the left or the right. So this would be minus one standard deviation. So that's one standard deviation less than the mean. So for example, if average heights were, the average male height is 5'10", that's 70 inches. Just as an example, let's say 70 inches. Standard deviation probably be like 4 inches, 3 inches. Think of it. That's okay, because we weren't really having a conversation. I'm just teaching, so it started like 5 seconds ago. Give me a second, man. Let's say that for male heights, the mean is 70 and your standard deviation is, let's say, 3. So if we go one standard deviation below the mean, which in our little example here would be 67 inches, then we go one standard deviation above the mean, which in our example would be 73 inches. What the normal curve, it's called the empirical rule, but it's like an estimate. What that rule would tell us is that 68% of the data falls within one standard deviation of the mean. So if it's true, if this stuff is true, that I just made up, the average height is 70 and the standard deviation is 3. If we go 3 each way from the mean, that gives us 67 and 73. 68% of all males will be between 67 and 73 inches tall. The bigger this standard deviation is, the more like spread out it'll be, but I don't even necessarily want to get into that yet. Put this like center line here too. So I can break that down even a little bit more and say, okay, well if 68% of the people are between 67 and 73, which is the idea of like one standard deviation below or one standard deviation above, what percent of people are in this section between 67 and 70? It would have to be 34, right? It's a perfectly symmetric distribution. So I could say at this point that 34% of people, 34% of males are between 67 and 70 inches tall. 34% of males are between 70 and 73 inches tall. Could you tell me what percent of males are less than 67 inches tall? What all the percentages have to add up to? 100. So, using that, could you tell me what percent are less than 67?
Yeah, 60.
Did you say 60?
60.
60. Yeah. Okay, so we've used 68% of it, right? There's 100 to go around. So what percent is left? 32. But doesn't that have to be evenly split between these two parts? So it would be 16%. Are you starting to follow what I'm trying to get to? Okay. So now if I go 2 standard deviations, so I'm starting at the mean, I went 1, that got me to 67 in this example. I'm going to go another one, so now I'm at 2 standard deviations below. What height would that be? 64 in our example here. And these numbers will change depending on the example, right? Like this could be temperatures in San Diego, temperatures in Michigan, it could be IQ, it could be SAT scores, it could be anything. These numbers will change. I'm just using this because it's easier to understand things if you have like an actual concrete example. 2 standard deviations above the mean. So that would be 76, right? So the rule there is that contains 95%. And these are estimates, but they're really close. We'll get into like how to find it precisely, but it's very helpful to be able to know the estimates. So then I can do kind of some math and figure this out too. So if I know it's 95% from here to here, I've already used 68%. What's left? Between 95 and 68. Oh, really? The more 27, right? 27. So 27 plus 68 would be 95. But that 27 needs to be split, right? So there's going to be 13.5% in each of those sections. So now I can ask you like a few more questions. What percent of people are between 2 standard deviations below the mean and the mean? So in our example, 64 to 70, what percent? And you would just add these two up, so 47.5. What percent are between 1 standard deviation below and 2 standard deviations above? I won't make you do the math, but you add up those 3, right? You see what I'm doing to get to that. If I go one more, you guys see that in the green? 3 standard deviations below the mean. So if I started at 70, 67, 64, this would be 61, right? 73, 76 over here, it would be 79. And then the rule there is 99.7. So pretty darn near all of your data. Not exactly all of it, but it's pretty close. And I can play that game again. So in the green area is 99.7. But within the red, I've already used 95. So how much is left? How much is left in the green? 4.7, right? I think someone said 2.35. You're just a step ahead of me. So if 95% is from here to here, and then I know I'm like in the way, and then I go here to here, it's 99.7. So I only added 4.7%. But that 4.7% would be split. So whoever I heard say 2.35%, that's what's there. And that will go there. So now I can say like what percent is between. I won't make you do the math. But if I said what percent is between -3 below and 1 above, you would just add up like these 4 numbers, right? That makes sense what I'm doing there. And then what's left? 0.3% is left, right? Because the green contains 99.7. Again, the whole thing always has to contain 100% of the data. So there's only 0.3% left, and that has to get split into 2 sections. So this little guy here is 0.15%. And this little guy here is 0.15%. That is in your notes, right? That little chart thing. If it's not, you definitely want to put it there. I think it is. Questions on that? So, alright, I don't want to erase it, but let's do this. Now I want you guys to make one. So let's say the mean temperature is, let's pretend we're in San Diego. Sounds nice. Mean is 75, and the standard deviation is, let's say, 5 degrees. I want you to make the whole chart table thing. Yeah, you're welcome to do it on your desk, your notes, and whatever. And then answer some questions about it, too. That's fine, actually. Those three questions. So I want you to make the big drawing chart thing, and then answer those questions. You guys know what the B/W means? This is between. So it's like percent between 65 and 80. Percent not between 75 and 85. Way too lazy to write all those letters and word between. So put the actual numbers. Or we can do below. That's one second. That's the B. Right in the middle. Is that right? Such a rebel. That makes sense. He forced it upon you. Yeah. It's always like it's the rule. The rule is 68, 95, 99.7. That's always those three, and then you can break it down to the watch the class. Like you pay attention for like 10 minutes and then start reading Harry Potter. I was like, do you need? He's like, no, I got it. And then he would just 100% every test. Okay, read all Harry Potter you want. And he was like social, like he got along with the kids in the class, even though he was in the 6th grade and they were, seniors for the most part. Like, impressive kid. As a student, you're like, I can't even do it. Check your below 85. Well, there's more than 3 though, right? So we got like sections decided. The 99.7. Yeah. You're trying to shortcut it there, too. It's just 3, isn't it? 65 and 80.
Oh, it's between.
That's
That's
me.
past.
That's past.
So it's
That's
okay.
like 81. Yeah. You get your calculators on every test in here. You get your calculator on the AP test. So like, don't ever feel like using your calculator is cheating. That's like painful for you. I'm sure not to use your calculator.
That's what I did as well.
It's in my backpack. I don't care.
It's just too far away.
It's right here, but it's good. Yeah.
It's not bad shaming you. So that's kind of what your numbers should look like.
Is this how it's supposed to
Okay.
look every single one? Like the 0.15,
The percentages, yeah. So
Yeah.
the numbers at the bottom will change.
Well, yeah. I just meant the percentages.
No, I just want to talk
Yeah.
about
Oh, yeah. Sorry.
Remind me to say that when I go through it. I do want to make sure we're clear with that. You say yours looks prettier.
Yeah, mine does look pretty.
Prettier than mine?
No, got it. Yeah.
That's impossible.
I mean, take away the few squiggles and the weird scrabbles.
Your student work.
It's the depths. We discovered this last time.
Alright, so let me go through these, then I just want to talk about real quick that it's the same thing every time, all the changes is these numbers. But between 65 and 80, so we're looking from here to here. So you add up the 3% in the middle, so 34%, 34%, 13.5%. And just think about it, like that should be a really high percentage, right? If the average is 75, shouldn't like a large chunk of people be between 65 and 80? That hopefully makes some sense. So this would be 81.5%. Percent below 85. So there's 2 ways you can do this. Using your calculator is not that big a deal, but I'm here, right? So I got 2 options. One is I can add up all of those numbers. But if I'm typing in my calculator, that's just kind of annoying to me. Maybe it's not to you, but plus, plus, plus. What else could I do that's a little bit less like keystrokes?
Subtract the other side.
From what? 100%. You know that to add to 100, right? So what do these 2 add up to? That's 2.5%, right? Think about it like money, like $2.35 and then 15 cents. So then you got 250. And you know that's now 200. So if there's 2.5% on this side of this line, there must be 97.5%. on that side. And then not between 75 and 80, or it's like 75 and 85, so kind of the same deal. You could say, okay, I'm going to add up. It would be this section, this section, this section, this section, this section, this section. Add up all of those. Or you could find out what percent is between 75 and 85, and then do what with that? Subtract it from 100%. So this is 47.5. So if I subtract that from 100%, I get 52.5%. Questions on what I did today? So I just want to show you. You don't have to even write this down. Just kind of watch. I can change the problem, change the numbers that go down here. I can't change the concept. Like, it's going to be the same stuff, just with different numbers. So let's say the average. They say that the average IQ is 100, with a standard deviation of I think it's 15. What they say. So then I can just do the same exact thing. I can go 100. What would go here? 115, 130, 145, and this way 85, 70, and 55. And then this, I forgot what I did before. This one before was what? It was 70 to 85 last time. So it was one standard deviation below to 2 above. So now it'd be 85 to 130. And now it's the exact same question. All I did was change like the numbers that go underneath. This one before was the percent below. On the last problem, I believe this was 85. Well, now it's just the percent below 130. And then this one was not between. I think it was like not between these two. Right? So it'd just be 101. So like your percents do not change. All that changes is kind of the numbers that dance around those percents. Does that make sense what we're doing? I'm going to give you time to work on your homework, answers on Schoology. I'll walk around and help answer questions, whatever. I'm starting to be a little concerned because as I'm going through this, I'm seeing, like, if you just do what I'm doing in here, you're not going to do great on the test. You have to be doing the notes. You have to be doing the homework. I'm not going through it because I'm time. So if you're not doing the notes and you're not doing the homework, that's kind of on you. And that's going to, I don't grade it, right? But I do grade it. There's going to be tests. So just make sure you're keeping up. Get a sense that some people are not quite. I don't even know who I'm talking to. I'm not accusing anyone, but just keep up on stuff. That's all I'm saying. Alright, so you got time to work, check over anything. Look at it. The one on the left, the one on the right, I'm not sure what that